Okay, so here is the next question. In this question, small m and capital M are arranged as shown. Now capital M, we know that can only move horizontally, right? Whereas a small m, its motion is slightly complicated, right? So here likewise we have done in the previous few question, we know that small m can only slide down vertically with respect to capital M, and it also moves along with capital M. So it has, you can mark two acceleration for small m. So the way you draw free body diagram of small m is something like this. So if its acceleration downward is small a and acceleration of capital M, let us say that is capital A, then small m will have two acceleration. Relative to the wedge, it is small a, and we have to add the acceleration of the wedge on small m. Okay. Now what are the other forces acting on small m? There will be a tension force, right? And the component of mg, this is mg sine theta downwards, and this will be mg cos theta, and that is the normal reaction. Fine. And since angle with inclined for capital A is, let me call this phi, because in the question it was phi, angle is phi, right? So a component of acceleration along the incline is a cos phi, and along this direction it is a sin phi, right? Right? So if I take my xy axis like this is my x and that is my y axis, I can write down Newton's second law of equation in a straightforward manner. So along x axis, I'll say that mg sin phi minus t is m into a minus capital A cos phi, right? This is along x-axis. Along y-axis, I'll get equation as mg cos phi, that is a force along the direction of acceleration a sin phi, minus n is equal to m into capital A sin phi, right? So this is, let us call it equation 1, and that is equation number 2. So how many variables we have right now? We have t, n and a, and small a also. So we have 4 variables right now. I need 2 more equation. From where can I get 2 more equation? From the wedge. Okay. So let us draw free body diagram of the wedge. So this is the wedge. This is tension T. What about this? That will also be same string, so same tension, that is also T. The acceleration of wedge is capital A, mass M, so there is mg force downwards, and there is normal reaction, let us call it N1, from the horizontal surface. Okay, any other force that we are missing here? This normal reaction is exerted by the wedge on small m, right? So according to Newton's third law, small m also exert same force, normal reaction, in opposite direction. So there will be a normal reaction like this, that is n. Okay, so these are the forces and acceleration on capital M. So let us write down equation of motion for this along x and along y axis. in order to do that, I need to take components of the forces and accelerations which are not aligned in x and y axis. All right. So if I take component of tension, this will be T cos phi for this tension, and its component downwards will be T sin phi. So it will have a component here T sin phi, right? Similarly, normal reaction can be resolved in two directions. One is vertically down, n cos phi. We call this as n cos phi, and like this it will be n sin phi, right? Now all the forces and acceleration are aligned in either x and y direction. So let us write down the equation for that. It will be T minus, let me write down here, T minus T cos phi plus n sin phi. This is the total force along x-axis, right? This must be equal to mass into acceleration capital A. Fine. So this is the third equation. Now fourth equation, you may think that you'll get by writing the equation along y-axis, but the fourth equation introduces another variable, n1. So number of variables will increase. Okay. So let us first write down the equation along y-axis. n1 minus T sin phi as this plus mg, this is equal to 0, right? Since there is no acceleration along vertical direction. But the problem is I get another variable n1. So even though I got 4 equations, now number of variables have been increased to 5. So I need another equation. That another equation is a constraint equation. There must be some relation between capital A and small a. What is capital A? It is the motion of capital M this way, and small a is a motion of small m in that direction. Okay. So assume that this wedge moves by a distance of x in this direction, x. So how much this small m will move down the incline? When it moves along x direction right hand side, it loosens up a string of length x, and that string of length x will be used for a small m to slide down, right? So even this small m moves down by x, right? So displacements are equal, and similarly rate of displacement and rate of change of displacement, all of them are same. So the relation will be capital A will be equal to small a. Okay, so the fifth equation is capital A is equal to small a. Fine. So now I have got 5 equations and 5 variables. I can solve these and get the answer. Okay, so these are the few questions that we have taken up today, and I hope that now you can you can see that if you apply your basics correctly, you will get the answer. All you have to do is split down the problem into its steps, and you'll see that every time you're doing the same thing again and again. Sometimes the problems can be made tricky by having the constraints. Okay, like for example here, finding out all these 4 equations are routine. The only thing which you'll see here tricky is finding out relation between small a and capital A. Okay, so just pay attention to detail. You will be able to solve all these so-called difficult questions that are regularly asked in JEE Advanced. Okay, so thanks for watching the video.